Hello everyone, this is Vijayalakshmi Subnalli and this is my YouTube channel Win Maths. Here, this YouTube channel helps to those which are studied second PUC NCERT syllabus. I solve the examples, problems and exercise problems based on the syllabus and topic wise. This video contains basically reduced syllabus of Karnataka PU Board 2025 and also some basic results of particular syllabus for KCET examination. Here in this session we have to discuss the definition of matrices, order of the matrix and possible order of the matrix as well as type of the matrix and some related examples. Now here the first concept is matrices. Okay, matrices. Here in that a single one called it as a matrix. Okay, first matrix. And why we study the matrix? Because the knowledge of matrices is necessary in various branches of mathematics. Matrices are one of the most powerful tool in mathematics. This mathematical tool simplifies our work to great extent when compared with other straightforward methods. The evolution of concept of matrices is the result of an attempt to obtain compact, simple methods of solving system of linear equation. Okay, mainly the matrix is used for solving the system of equations. It is linear as well as non-linear functions. Okay, before then sometimes in our real life we also use the matrix, but we don't know exact how we use. Okay, here we study the matrix and definition now. Matrix is an order pair rectangular array of numbers or function. Or it is a matrix is an ordered rectangular array of numbers or functions. Okay, it means numbers or functions are written in a rectangular array means box. Okay, array means box. Okay, the numbers or functions are arranged in a rectangular box manner. Okay, here for example 2, 3, 4 and 5. It is the one of the rectangular array. The arrangement, it is two values are arranged in row and column. Okay, a matrix is an order rectangular array of numbers or a function. All the numbers here, these numbers are called as elements. Okay, these entries or numbers are called as elements, or sometimes we written as functions. Some functions we are written. Okay, these are real values or real entries are called as elements. Other than real entries, then they call it as functions. Okay, now next here 2 and 3. Okay, here 2 and 3 are written in row and these are the columns. What is the row and column? The horizontal line of the elements. Okay, this is the horizontal line. Okay, horizontal line. This is vertical line. Okay, horizontal lines elements. Okay, horizontal line elements are here, vertical line elements. Horizontal line elements and vertical line elements are called as a column and row. Horizontal lines are called as a row, sorry, it is row, and these are columns. Okay, these are columns. Now order means, okay, here order of matrix. The next concept is order of the matrix. So the numbers can be expressed in a rectangular box is known as the matrix. Here the numbers are called as the elements or function. The horizontal line elements are called as a row, and the vertical line elements are called as a columns. Then order of matrix. Here a matrix having a matrix having m rows and n columns. M rows and n columns. Okay, here don't know the exact number of rows as well as exact number of columns. Okay, that's why I'm taking m means number of rows, n means columns. Is called as the order of matrix. That is, number of rows and number of columns are called as the order of matrix. It can be written A be a matrix. Okay, A be a matrix of m rows and n columns. This is called as the order of the matrix. Okay, this is called the order of matrix. That is m rows and n columns. Generally, we have written the elements A11, A12 up to so on for An. Again A21, A31 up to so on here. Okay, then the element, this one is called as Mn because last row, that is mth row, and last column n column. Okay, now here we consider generally. Then in general, what we written, A be a matrix. It has the elements A11, A12 up to so on for A1n. Here A21, A22 up to so on for A2n. Here AM1, AM2 to so on here for A into M1. Here n represents the number of column. M represent the number of rows. Okay, here there are m number of rows because exactly we don't know the how much rows. Okay, then it is called as the number of columns. Okay, here n is the number of column. This is the element. The last element will be m into n. So this is called as the order. Okay, order of the matrix. Here this is the generally. So usually we present or we represent the matrices in general form of, that is Aij of m cross n. Here A be a matrix, always matrix written in capital letter and the elements are written in a small letter. Here this lowercase shows the order of the matrix. This lowercase shows the order of the matrix. Okay, this is the general form of the matrix. This is the general form of the matrix. General form of the matrix, that is A is equals to Aij m cross n. Okay, A means element, I represents the where Aij, it represents the element, I means row, and J means column, and m cross n becomes order. Okay, these should be remember. Okay, these are the very important in the matrices. Okay, now now we can write it or finding the possible orders. Okay, here we defining the definition order of the matrix and defining the or possible orders. So the number of elements, okay, the number of elements can be written in row or column. Okay, here the point is we can also represent any point. We can also represent any point. We can also represent any point x comma y in plane. In plane we represent x and y. This is on x axis and this is on y axis. But in matrix we have expressed in row or column. Okay, we have expressed in matrix. In matrix we have expressed as a column row. We can express as a column or row. First, always in matrix, always first written rows then column. Okay, here it can be expressed in two ways. Any element more than one, it can be expressed in two ways. Okay, that is one way is x comma 0 or another way x comma 0. Okay, now observe that this is the way we can also express the elements or vertices in the form of matrix. Okay, now then consider or finding the possible orders. Okay, possible order means we have mn elements. Okay, we have mn elements in the matrix. If A be a matrix, it has m cross n of order. So the element should be the number of elements is the number of elements present in the matrix is m cross n. For example, if a matrix containing a 4 elements, so 4 can be written in how many ways? That is 1 into 4, 4 into 1, and another one way is 2 into 2. Therefore, this is the possible orders. This is called as the possible orders. Possible orders always depends on the number of elements which are present in the number of elements which are present in a matrix. Okay, now we have one example. That is, here we have one example question. That is, example, if a matrix contains, example 1, if a matrix contains if a matrix contains 8 elements, then what are the possible orders? What are the possible orders it can have? Okay, now here A be a matrix, it has 8 elements. Okay, then 8 elements can be expressed in how many ways? That is first 1 into 8, 8 into 1, then 4 into 2 or 2 into 4. Otherwise, nothing. It can be expressed in 4 ways. Therefore, the possible order is 4. Possible order is 4. It can be written in a 4
Here
next
ways.
Sometimes they given the general element of the matrices, then we have to construct the whole matrices using the general element. Okay, for example, we have to consider now. Example, that is construct a 3 cross 2 matrix. 3 cross 2 matrix whose elements are given by Aij is equals to 1 by 2 I minus 3j. Okay, this is the general element. Okay, by using the general element we have to construct a matrix. Okay, here A be a matrix of order. What is the order? 3 cross 2. It means there are 3 rows and 2 columns. The possible elements, okay, 3 means 3 rows, okay, 2 columns, A11, A12, A21, A22, again A31, A32. Here there are 3 rows, okay, 1, 2 and 3, 1 and 2 columns. Therefore the order is 3 cross 2. Here now substituting the values in ij, then we get the element. Okay, here first A is equals to, the first element is A11. We have to substitute the values here. Okay, first A11 is equals to 1 divided by 2. Substitute I is equals to 1 minus 3. We get 2 by 2, that is 1. The first element will be 1 here. Then 1 2, 1 by 2, 1 minus 6. It is 6 minus 1, 5 mod of 5, that is 5 by 2. 5 by 2. Again we consider 2 1, 1 by 2, 2 minus 3 into 1, 1, 2 minus 1, that is 1 by 2. Here next element 1 by 2. 4 A22, 1 by 2, 2 minus 6 becomes 4 by 2. It is 2. Next A31, that is 1 by 2. 3 means I becomes 3. 3 minus 1, 3. It becomes 0. Then A32, 1 by 2. Then 3 comma 2. 3 minus 2 into 3, 6. 6 minus 3, 3 by 2. Here the element is 3 by 2. This is the matrix. Okay, this is the matrix they given. Okay, they have said construct, which is the solution of the matrix. We have constructing the matrix. This is also one of the type of the question which is asked in multiple choice questions. Okay, now then we discuss the types of function here. First, types of function, matrix. Okay, types of matrix. Here there are so many matrices are there. Okay, there are so many matrices are there, but in your syllabus they given only 7 types of matrices. Okay, first one is column matrix. Okay, first one is column matrix. Generally, what we say column matrix means it has only one column. Okay, it has only one column. What is the types of matrix? First one is column matrix. A matrix is said to be a column matrix if it has only one column. The matrix has only one column, then we can call it as a column matrix. Generally, what we written, A be a matrix of the form Aij be an element of order. It has one column means then the row should be m cross and n, m cross 1. So the column, the first one represents row, here column. The column should be 1. Okay, column matrix. For example, A be a matrix. Okay, 1, 2, 3, 4. This is the order of the matrix will be 4 cross 1. Okay, the column should be 1. Then it is called as a column matrix. Next, row matrix. Okay, row matrix. Tell me, what is that? It has only one row. Only one row. Any matrix with order m, here 1 cross m. Okay, the row matrix contain only one row. That is, generally we say that A is equals to Aij be an element of order 1 cross n. Then row should be 1. Here taking an example, A is equals to 1, 2, 3, 4. Here 1 cross 4. There are 4 elements, so 4 column, then 1 row. It should be a 1 row. Then next one of type of the matrix is square matrix. Okay, that is square matrix. What do you mean by the square matrix? Okay, square matrix means it has order. Okay, if a matrix has number of rows is equals to number of columns. Okay, it has the order m is equals to n. Here number of rows equals to number of columns. Okay, if a matrix is said to be a square matrix if it has number of rows is equals to number of columns. Okay, for example, or generally we written it as Aij be an element of order m cross m. Okay, it is of the order m cross m. Both are equal. For example, A be an matrix of order should be same. That is 2 cross 2 means A11, A12, A21, A22. Therefore, both are should be same. The order should be same. Okay. Now, here there is a one point in square matrix. This is the one of the important point. If A is equals to Aij be a square matrix, of order. It is a square matrix of order m. It means it has m and n number of rows and columns. Okay, then the entries of A11, A22, A33, up to so on for AMM. Okay, are called as diagonal elements. Okay, diagonal elements. For example, considering a 2 cross 2 matrix, B is equals to 2 cross 2 matrix 1, 2, 3, 4. Here these elements are called as the diagonal elements. Okay, that is, they are called as the diagonal elements. In generally, we have written it as A11, A22. These are called as the diagonal elements. Okay, then the next type of the matrix will be diagonal matrix. Diagonal matrix. Definition of the diagonal matrix. Okay, we defining the diagonal matrix. Say a square matrix B. A square matrix B has the n elements Bij of order m, because number of rows and number of columns are equal. That's why it is of order m cross m. Then if okay is said to be diagonal if all its non-diagonal elements should be zero. It means, for example, ABR matrix, the elements are 1, 2, 3, 0, 0, 0, here 0, 0, 0. That is 3 cross 3 matrix. The number of elements are 9. Here 9 elements are there. Then these elements are called, okay, these elements are called as a diagonal elements. These are called the diagonal elements. Okay, other than the diagonal elements are called as a non-diagonal elements. Other than the diagonal elements, all the elements should be 0. Then it is called as a diagonal matrix. Okay, next one, scalar matrix. Okay, scalar matrix. Here also consider the square matrix. Okay, here also we considering a square matrix. A square matrix Aij of m cross m. The diagonal elements, okay, the diagonal elements are same. And non-diagonal elements are 0. Okay, for example, while taking an example, ABA matrix 2, 2, 2. Here all the diagonal elements are same. Otherwise, taking another one example, here B, B, B. Okay, the all diagonal elements should be same. Non-diagonal elements must be 0. In diagonal matrix, the diagonal elements are maybe equal or irrespective. Okay, the diagonal elements are irrespective. In unit matrix, the last one is unit matrix. Okay, unit matrix means similar to the scalar matrix. Similar to the scalar matrix, that is, the diagonal element should be 1 or unity. Okay, here a square matrix A is equals to Aij m cross n. The diagonal elements are 1, than the non-diagonal element should be 0. Unit matrix means the diagonal element should be 1. The diagonal element should be 1. Okay, next, last one, that is 0 matrix. The last one is 0 matrix. 0 matrix means all the entries should be 0. Okay, all the entries are 0. All entries should be 0. Then it is called as the 0 matrix. Here all the matrices are completed now. Finally, 0 matrix, it means all entries should be 0. All entries should be 0. Okay, now types of matrices are over. Okay, what are the types we have discussed now? Column matrix, row matrix, square matrix, diagonal matrix, scalar matrix, unit matrix, and 0 matrix. Okay, now comparison of matrix. Okay, comparison of two matrix. Comparison of two matrix. Here in that case we have discussed equality of matrix or equal matrix. Equality of matrix or equal matrix. If A and B are two matrix. If A and B are two matrix, that is A be a matrix, so Aij, and B be a matrix Bij. Okay, A and B are two matrices, are said to be equal. Okay, are said to be equal. Are said to be equal. There are mainly two conditions. One is their order should be same. Okay, their order should be same. For example, if A has the order 2 cross 1, then B should be 2 cross 1. Then, okay, the corresponding element of matrix A. The corresponding elements of matrix A is equals to the corresponding matrix of element B. Element of matrix B. Both should be equal. Okay, there are two conditions when we say two matrices are equal. One is the order should be same, or the order should be same, and the corresponding elements of matrix A is equals to the corresponding matrix, the element of the matrix B. Here A be a matrix 1 2 3 4 containing 4 elements. The order should be 2. And B be a square matrix. It is also containing these elements. Then we say that A and B are equal matrices. Okay, here there is a one example. Okay, there is a one example question. Now, if A be a matrix having the elements x, y, 2z, 3. Okay, and of order 2 cross 2 and B be a matrix of order 2 cross 2. It has the elements 3, 4, 6 and W. Then find the values of X, Y, Z and W if A and B are equal matrix. If A and B are equal matrix. Okay. They given A and B are equal matrix. So they given A and B are two equal matrices. Okay. Here the possible order is they given A and B are equal. Therefore, A is equals to B, X, Y, 2Z, 3 is equals to 3, 4, 6, W. The corresponding order should be same and the corresponding value should be equal. Therefore, X is equals to 3, Y is equals to 4, 2Z is equals to 6 and W equals to 3. Here Z becomes 3. The values of X, Y, Z and W is X is equals to 3, Y is equals to 4, Z is equals to 3 and W is equals to 3. Okay. In this session we discuss the here in this session we discussing the properties of the matrices and types of the matrices, the possible order of the matrices and some examples, related examples. In this session we discuss the exercise problems and the next concept of the matrices we have discussed in next section. Okay, thank you.